Welcome back, focus learners, to the Explainer. We're jumping right into a really fascinating, multi-layered topic today. OMI as a computational ontology. Now, if that sounds like a mouthful, stick with me. We are going to build this up piece by piece. We're looking at a deeply structured model that literally asks what it means to exist, to relate, and to be validated inside a computer protocol. It's a massively ambitious concept, so let's just get right into it.
From darkness, boundary. From boundary, declaration. From declaration, word. From word, citation. From citation, attestation. This quote perfectly sets the stage for what OMI is trying to achieve. It's this profound origin story bridging theology, geometry, and computer science. It starts with total void, creates a boundary, and builds all the way up to human attestation. It is a highly disciplined progression of existence itself.
To make sense of all this abstract philosophy, we're going to follow a roadmap. Starting from the null seed, the first reversible relation, a compass of interpretation, validating with the tetragrammatron, Latin squares in P2P, and finally, agreement without forced sameness. Section 1, starting from the null seed. So what actually is a computational ontology? Well, it's not just database rows or graph nodes. It's a way of defining the actual nature of being inside a protocol. It acts as a formal rulebook for how data transitions from completely unobserved to related to witnessed and finally to actually appearing on a screen. We begin with the null seed, which is null.null. And the absolutely crucial thing to grasp here is that this isn't meaningless nothingness. It's not a broken error state. It is a bounded absence. It's an absence that is primed and waiting to participate in a relation. Think of it less like a blue screen of death and more like a blank text box, blinking, just waiting for your input. Down at the raw computational byte level, this bounded absence is simply 0x00. It's the absolute ground floor, the very first position from which any future relation can be measured. You can think of it as the ultimate anchor point for the entire architecture. And this brings us to the genesis moment. The center declares and the radius relates. Imagine taking the sharp metal point of a geometry compass and planting it firmly into a piece of paper. Bam! That is your declaration. Then the pencil drawing the circle around that point, that's the relation. Suddenly, out of nowhere, we have a boundary. The null seed unfolds into a root pair, and the protocol comes alive.
Section 2. The first reversible relation.
The elegance of the math really shines when you see how this first reversible relation cell maps across entirely different domains. In geometry, you have the 2 points of a zero sphere. In standard binary computing, it's a 0 and a 1. In the Lisp programming language, you've got char and CDR. And in OMI's specific architecture, it's declaration on the left pole and definition on the right. It's the exact same universal structure of relation, just viewed through different computational lenses. Section 3. A compass of interpretation. Okay, as our computational universe expands, we run into some esoteric names that sound like they belong in a sci-fi novel, right? Metatron, tetragrammatron. But it's absolutely crucial to know this isn't a hierarchy of domination. Think of them more like gears in a complex watch. Metatron observes, tetragrammatron validates, Omicron holds the framing horizon around it, and the OMI ring acts as the witness. Each entity handles a specific, necessary binding of the exact same underlying relation. Section 4. Validating with the tetragrammatron. So how do we actually validate truths without a central authority? The tetragrammatron acts as a blackboard control shell. To put it simply, it's like a highly strict traffic cop at a data intersection. It decides which knowledge source can act, stepping in exactly at the boundary where the fold of our data becomes a carry-forward state. It is literally just a guardrail. It computes an XOR reduction of the witnesses, which is essentially a mathematical checksum verifying that all the puzzle pieces fit together perfectly, with zero gaps. And here is the most important part. It explicitly stops before parsing, projecting, or interpreting any meaning at all. It just checks the geometry, confirms the structure is whole, and leaves the actual human meaning entirely up to you.
Section 5. Latin squares and P2P.
Things accelerate here. OMI uses the mathematics of Latin squares, functioning as reversible finite resolvers. Think of this like a perfectly balanced deterministic game of Sudoku. Because of the math, if you have any two coordinates, you can automatically recover the third missing piece.
Attestation plus attribution gets you the discovered point. Attestation plus the discovered point gets you the attribution. It is entirely 100% reversible. This mathematical certainty is exactly what makes OMI a flawless architecture for decentralized peer-to-peer networks. Because of that Latin square logic, peers don't need to ping a central server or download some massive global graph. They can resolve missing information locally, deterministically, and with absolute certainty. For us, the users, this means true data sovereignty without ever having to ask big tech for permission.
Section 6. Agreement without forced sameness. Which brings us to the real human application, the climax of why this abstract architecture was even built. Why does OMI exist? Well, it isn't here to declare final truth. It isn't here to force one definition of God or forcefully assign a global sign value to people's words.
Here is the big aha moment. The entire computational ontology exists to protect the hyphenated bridge between on my intelligence, OMI, and in my opinion, IMO. It provides the unbreakable mathematical infrastructure so that I can make a declaration based on my intelligence and you can receive it and process it securely in your opinion. It literally protects the space between us.
I'm going to leave you with this highly provocative thought. Under this protocol, you and I can look at the exact same validated data address, and we might resolve it completely differently based on our own frames and our own contexts. And that isn't a failure of the system. That is the very definition of true harmonization. It's a framework for absolute mathematical agreement without ever demanding forced human sameness. If we can build a future web based on structural truth rather than forced ideological consensus, whose intelligence will you finally be able to trust in your opinion? Thanks for exploring this one with me, Focused Learners. Catch you next time.